Hello students, today we're going to be solving a system of equation by elimination. Don't forget to take notes as you go and complete the survey that follows the video. So far we've solved a system through graphing. These notes are going to be continuing doing in a different way, known as elimination. The way we do this is when we have two equations that are in standard form. So remember with graphing, whether it be an equation or inequality, it always has the y followed by mx plus b. So in this we have ourselves standard form. So please write this down. The standard form is in the form of ax plus by is equal to c. So here are the steps that we take to solving a system of equations. Please make sure that these get written down into your notebook. Step 1 is to line up the equations. So we put x's on top of each other, y's, and numbers all on top of each other. Step 2, we're going to determine which variable to eliminate. So we're looking for variables that have the same coefficient. It could be positive and could be negative. It could be one of each. So just keep an eye out for numbers that have, or letters that have the same number in front. From there, we're going to solve. This means we're either going to use same sign subtract or different signs we're going to add to eliminate a variable, and we'll solve for one of them. From there, we're going to plug that variable that we just solved for back into one of the two equations and get our second variable. The most important thing here is we're going to create an equation or create a coordinate in the form of x comma y. Now sometimes it won't be x and y. In that case, make sure you're using the variable that is in alphabetical order, goes first, followed by the y, or the second one. So here's our first example. Step 1 is to line up the equation. As you can see, x's are on top of each other, the numbers are on top of each other, and y's are on top of each other. So now to determine the variable we're going to eliminate, we're focusing on the one that has the same number. So if you look at the y values, both of those have 5y and negative 5y. And that's what we want to have happen. It's okay that one is positive and one is negative. So then we're going to go through and solve. The point of elimination is to eliminate a variable. So we're going to choose either adding or subtracting in order to get rid of them. If they have different signs, we're going to add, because a positive 5 plus a negative 5 cancel them out. However, 5 and negative 8 add up to a negative 3x. 20 and negative 29 add up to a negative 9. So when I divide both sides by negative 3, we get back a positive 3, because negative 9 divided by negative 3 is positive 3. So now we're in our final step. Our final step is to substitute this back into one of the two equations and solve for y. So it doesn't matter which one you put it back into. I'm going to put it back into the first one because it has a bunch of positives. Now make sure you're substituting into the correct variable. Since I solved for x, I'm going to need to put the 3 into where the x value is. So I'm going to leave 5y as just 5y. From here I'm going to multiply. 5 times 3 gives me the value of 15. So I have 15 plus 5y is equal to 20. I need to now solve for y. So since the 15 is positive, I'm going to subtract it from both sides. And 20 minus 15 is equal to 5. And now I have 5 times y. The opposite of multiplying would be to divide both sides by 5. So I get y is equal to 1. So now I have myself an x value, found right here. I have a y value right here. So now I'm going to create my coordinate, and it's always alphabetical order. So since the x value is 3, that's going to get listed first. The y value is 1, that's going to get listed second. So the answer to this would be 3, 1. Remember with this system, it represents points on the coordinate where the two lines are intersecting. With inequalities, it's the points that are all found within the shading that overlaps. So this is a coordinate where if I were to graph those two equations, I would end up getting as the point of intersection. Let's take a look at another example. So for this one here, once again, we're going to identify the variable that has the same coefficient. The two x's have the same number in front, which is negative 1. So once we would need to also get rid of them, so since they have the same signs, we're going to think, well, same signs means we subtract, because a negative minus the negative is going to essentially be a 0. So negative 1 minus negative 1 is 0. They cancel out. Negative 5 minus 9 is negative 14y. And 2 minus 2 is 0. So now I divide both sides by negative 14, and I get the y value of 0. Now remember, we need to solve for x, so I need to put this back into our equations. Now it doesn't matter which one. Let's do the second one this time. So I have negative x plus 9. And now since I solved for y in this problem, I'm going to put a 0 in for y and set that equal to 2. When I multiply 9 times 0, I get the value of 0, so it's as if it's not there. So I have negative x is equal to a positive 2. I don't want negative x, I need positive x. So what I need to do is divide both sides by negative 1, and this gets rid of the negative on the left side. So my final answer here is x is equal to negative 2. So as before, we're going to say, all right, well, our y value is 0. Our x value is negative 2. I now can create my coordinate. As always, the x value goes first, so I'm going to list the negative 2 followed by 0. Now remember, all these represent, if I were to actually graph these two lines here, that would be the point of intersection. One last example is going to be a word problem. So in this one, the senior class at High School A and High School B planned separate trips to Yellowstone National Park. The senior class at High School A rented and filled 13 vans and 6 buses with 402 students. So the first thing with this is we're going to create an equation for High School A. It was 13 vans, so I'm going to represent that by 13V. The next thing says 6 buses, so I'm going to use 6V. So V stands for the number of buses, V stands for the number of vans, and B stands for the number of buses. And then we have a total of 402 students, so it's equal to 402. And now I'm going to repeat that process with the second school. So High School B rented and filled 13 vans, so we're also going to have 13V, and 14 buses for them, so we have 14V. And they have a total of 626 students, so it'll be it's equal to 626. So our goal here is to figure out how many students can the van hold, and how many students can the bus, or how many students can the bus carry. So we're going to figure that out through our method of elimination. So once again, we want to put the variables on top of each other. So we have 13V over 13V, 6V over 14V, and numbers over numbers. And we're going to go through that same exact process as we did previously. So in this problem here, the 13V's are the numbers that are the same. Same signs mean we subtract. So when I subtract 6 and 14, I get negative 8B. And when I subtract 402 minus 626, I get negative 224. So this is a good thing that I get negative 8B and a negative 224, because when I divide both sides by that negative 8, I essentially am going to get back my positive, because negative divided by a negative is a positive. So B ends up being 28. Now, I need to find how many the vans hold, so I just found out how many buses hold. So what I need to do now is substitute that value back into B. Once again, it does not matter which one you put it back into as long as it's going in for B. So I have 13V plus 6, this is where I'm going to substitute in my B. I did it into the first equation, is equal to 402. So as before, we're going to take the numbers and multiply them. So 6 times 28 is 168. So I have 13V plus 168 is equal to 402. I'm going to subtract that from 402. When I do so, 402 minus 168 is equal to 234. And I'm going to finish this up by dividing both sides by 13. So what I find here is that V is equal to 18, which means the vans hold 18 students. Okay, so what you're going to say here is that buses, they'll hold 28 students. I'm going to abbreviate that as TU. And that the vans, they hold 18 students. Okay, so we want to write some kind of sentence there. In conclusion, we want to eliminate our variable that has similar coefficients. Same signs subtract, different signs you add, and our goal is to eliminate the variable. Again, we want that one to be 0, so that's how we're choosing the difference between adding or subtracting. When you're writing an equation from the word problem, keep the right information together. Make sure you're writing in standard form. If you have any questions, please make sure you bring them to class tomorrow. Please complete the survey that follows this video. Make sure you understand how to write an equation and solve them. I'll see you tomorrow.